901 words, right on target. Here's the script. The suffocating reason your lungs hoard the pressure of a rising ocean floor from you. And in 2011, off the coast of Japan, it lifted 50 meters of seafloor in under 3 minutes, then buried an entire coastline under black water. You never felt it. Your body isn't built to register a force that size. That gap between what you feel and what's actually happening down there, that's exactly why this trench is so dangerous. Right now, thousands of feet beneath the surface, a trench near Japan is doing something it shouldn't. It's rising, not sinking like every textbook says a trench should. Rising. Scientists first caught it on satellite radar, then on seafloor sensors anchored to the abyss. Centimeters a year, then centimeters a month. If you live anywhere near a coastline, the Pacific Northwest, Japan, Chile, Indonesia, this isn't background noise. This is the ocean floor storing a debt. And debts like this get paid in seconds, not years. The last time a trench like this let go, it moved a nation 12 feet closer to America. Here's what's actually happening. Trenches form where one tectonic plate dives beneath another, plunging into the mantle. That's supposed to be a one-way trip down. But the rock isn't smooth. It catches. It locks. And when a subduction zone locks, the overriding plate doesn't just sit still. It gets dragged down with it, like a rug bunching under a foot that won't stop pushing. Then slowly, the front edge of that rug lifts. That's your trench floor rising, not because the plate is escaping the depth, but because it's being squeezed upward by a fault that refuses to slip. Ocean floor benchmarks near the Japan Trench have measured this bulge growing for over a decade. It's not a rumor. It's not a model. It's meters of solid seafloor, physically rising, recorded by instruments sitting directly on top of it, while the plate underneath keeps grinding toward a break point nobody can schedule. Now here's the part that broke a few assumptions. Researchers expected rising seafloor to mean the pressure was leaking out, slow, safe, painless. The opposite turned out to be true. Every centimeter of uplift measured near a locked trench correlates with more stored strain, not less. It's the same physics as a bowstring pulled back before release. The bulge isn't relief. The bulge is the reload. And along parts of the Japan Trench and the Cascadia margin off Oregon and Washington, methane is now bubbling up through cracks that weren't there 5 years ago, gas escaping from rock being squeezed hard enough to fracture. In March 2011, the Japan Trench had been rising for years, locked and loaded, storing energy nobody could see from the surface. Then it let go. In under 3 minutes, the seafloor near the trench axis shot upward by an estimated 10 meters and lurched sideways by roughly 50. That's not a shift. That's a wall of rock the size of a skyscraper moving faster than a car merges onto a freeway underwater, in total darkness, half a mile down. The energy didn't stay in the rock. It punched straight into the water column above it, stacking into a wave that reached heights of over 130 feet when it finally crashed into Miyako. Nearly 20,000 people died. And the terrifying part, the trench is still doing this. Right now, in 2026, seafloor geodesy stations along Cascadia, off the Pacific Northwest coast, are recording the exact same signature. Slow uplift, locked faults, stored strain building toward a release event scientists estimate is centuries overdue. Your lungs, your ribs, your entire nervous system evolved to detect threats you can see, hear, or smell. A slab of rock rising 2 centimeters a year under 400 feet of seawater sets off none of those alarms. There's no smell of ozone, no gust of wind, no shadow crossing the sun. Just water, sitting still, hoarding a countdown your body has no sensor for. Scientists have responded the only way they can, not by stopping it, because nothing stops a tectonic plate, but by watching it closer than ever before. Ocean bottom seismometers, GPS acoustic buoys, fiber optic cables laid along the seafloor like nerve endings, all of it feeding data back in real time, hunting for the moment uplift accelerates past its normal creep. Japan rebuilt its entire coastal warning system around lessons from 2011. The U.S. Pacific Northwest is racing to do the same for Cascadia, a trench with the same locked, rising signature, overdue by their own estimates. but every model agrees on one thing: uplift can be measured. The moment of release cannot be predicted, not to the year, not even, most researchers admit privately, to the decade. So the trench keeps rising, a few centimeters more this year than last. Somewhere beneath a fishing town, a surf break, a coastal city you might live in or visit, the seafloor is quietly climbing toward a version of itself it held decades ago, right before the last one broke. Nobody can tell you when the reload finishes. Nobody can tell you which trench is next. All they can tell you is this: the floor beneath that ocean you love isn't resting. It's rising, and it's counting down toward something no sensor has clocked yet.